the PPTs reaches to you?
Good morning, sir. It will take some time to load the presentation which you are relaying from your side due to online lag.
Yeah. Is it able to you, madam? Sir?
Not yet, sir.
Retry. Window. Okay, just start the introduction. So, what I'm going to discuss today is data analysis tools for research, and the topics I like to cover, with starting with the just like introduction about the statistical softwares used, that I like to have a brief introductions. And the understanding the scales and tool selections, that is the second part I like to discuss. A third part will be the discussion about the few statistical tools and the usage and applications, where to use, how to interpret that the information I'd like to discuss with you. This is what the today's the agenda I planned. Okay, so hope you have been aware of this, the statistical tools that we've been, like all the statistical the social sciences who carry the topics and research in social sciences, all are aware of about the SPSS. Apart from the SPSS, there are the many software tools are there. There are the professionals and academicians and researchers have been using the softwares, because the manpower is limited today's world. The ICT is predominantly used to even in research part also, because the similarly the other how you've been giving the importance computers in the other fields, like similarly the research also the computer softwares. The softwares are here. It has been many softwares like starting with the SPSS, startup, views, mini tabs, or EPI info and CSE Pro. All these tools which have been using predominantly. See, it depends on what kind of research you have been carrying. Something like a specific research that you have been doing apart from the social sciences, like especially in the science field. So you have to go for something like apart from this, like R is suitable for the R in MATLAB is suits for the majority of the science and other, even the social science research. And free software is also, you're aware of this. You've been R is the free software. So still not reaches to you, sir.
The slides are visible, sir. You need to click the slideshow option by either pressing F5 or clicking on the buttons.
Yeah, I'll do this. I'll do, sir. I think I'm doing so. Is it visible, sir?
Full screen is not visible, sir. We can see your slide PowerPoint.
I made it as a full screen only. Like what you say, it is um, slideshow.
It might be due to the network lag. You can exit the slideshow and you can change the slides manually, sir, so that we too can view it on real time.
Okay, okay. Is it not appropriate, sir? Is it not appropriate, sir? The way it is presented, is it appropriate, sir?
Yes, sir. We can visualize the slide. Just change one or two slides so that we can know whether it is changing or not. Just click on
Changing, sir.
on the
Changing, sir. Is it?
1 minute, sir. It will take few seconds to change over here.
Okay, sir. Mini, is that your user? Hello?
Um, so the slides are not changing, but
No,
it is
sir.
visible.
After sharing one more time, I'm not going to slide share, what do you call, slide share option. I'm not going to use. I'll use the one. There is an issue with even I had an issue with the sharing in Teams only that we had a issue, sir. Okay, I'll check, sir.
So there is an option. Would you like to do it, sir? Try it out.
1 minute, sir. I'm not able to come out. It's still in the. I'm not able to come out, sir. That's the reason. One minute, sir.
No issue.
Yes, sir. Window. Is it visible, sir? Sir, is it visible, sir?
It's loading, sir. It will.
Okay, I'll just start with this. inform me, sir, so that I can share. So, like many researchers who can be using statistical software, with the help of statistical software, they are doing many research nowadays. No hindrances, like very customized oriented softwares are there. Like you make the simple programming, so you should aware of. Like R programming and other softwares, you have to use the basic syntax. You should be aware of this. But thing is, after its introduction on the SPSS. See, SPSS now it is popular and they among many social science researchers. They have been using this SPSS user friendly and more you learn self-learning capacity. That is the idea the SPSS has been brought into this, and moreover, there are the other professional softwares are there like Stata and the mini tabs and so these are the software which is uh, people are professionals are more used. And one by one, let me explain. Apart from this, all this software which is exclusively mentioned of this the statistical softwares, the Excel also has been used. Excel, it is people are using the Excel as in one of the softwares. It's like what we call it, it is used for the many purpose, and there are the few tools which you can be used with the help of Excel. Like Excel has the specific option is called the you can add ins, you can make the data analysis option, which is there in the add-ins button. You need to go and add ins by the through the buttons. There is an option which is you have to go add-ins, select the data analysis. So generally it may not be available in the regular window, the Excel window. You need to add ins by using the add-ins category, like how you've been adding this like macros and other uh, the the options like data analysis also is one of the options. And you can run this very easy to uh, what you call use the data, and it's like very easy to very easy to feed the data and get the output. That is what it is the Excel is gives. And moreover, the earlier the all these statistical mathematical functions we have been using through the Excel, which may not have a very elaborate like one click, like how the SPSS give the output, may not be having in the Excel. But the Excel now it has come up with the data analysis. That is what I'm been talking about. This is a tool pack. You have to choose from the it is an add-ins buttons. And the next is R and MATLAB. What is the R and MATLAB? Which is R is that the impressive there's a collection of library which is people are using as an R as an open source, because there are the people who the community supports the open sources. They don't want to depends upon the one softwares, because you mean aware of this the even the open sources, that is a sorry, operating system, there is a open sources. There are the people are advocating you cannot be depends on what on the paid versions. You need to learn the open sources. There are the community who supports that. They are actually using the R as in programming, and moreover the R is using not only the social science studies, and it uses the many even the science studies also we can be used. But it requires a little bit of language. The syntax, I can say, it's mentioned not like the programming code you have been experienced with your C++. That is not that complex. It is a very simple, and you can learn that. It is a very logically you need to be narrated thing as a syntax parts. And the MATLAB also is having that comprises the MATLAB also equally is giving an importance. The people who are users, even this MATLAB, especially the people who are doing the science, the finance research, they can use this MATLAB as things. And MATLAB is good for the as it's giving an output, and the R program is good for this its output, and the MATLAB is in the graphics. That's what the difference between the R and MATLAB. And the SPSS, now SPSS are popularly knowing everyone, the practitioners, because this not does not require any kind of a training. You can be understand by it's the only thing is you need to how to interpret. That's what uh, knowledge is required. Apart from that, the the SPSS, it doesn't require the much knowledge. That is what it is. That such way that, and all kinds of the programs, it is whatever the industries are the complex analysis, complex statistical used in the as developed by the SPSS. After the taken care of, it is, and moreover the many softwares are there, but why I've been talking about uh, just what is giving should be the authenticity. The people using the and SAS and Stata. SAS and Stata, which is the SAS is the procedures. It looks like a it has a make a way you have to feed the data, the what do you call it? Like I can say this as like a grandfather. You have been asking your grandfather how he narrate his own life and make it a full-fledged like you're just asking them, or you're just in a statement, but just one single words. I think he's giving a statement, like very huge statement. How is his life? All those things. SAS and other things will give, but it is sometimes it requires very more, and more of the people not like this, more into the IT, and this data is even the data softwares, and you're using this as a time because have to be depends on the SAS and its data. Like very few people are using the professionals and practitioners. They have been using SAS and data. They exclusively there are sometimes the university something the people assistant, you would have seen that they exclusively mentioned that you should possess the SAS and knowledge that because it is or otherwise they're mentioning that efficiency is required to work with that numbers. They're mentioning the Minitab. It's a very and like a similar like uses we are going to use them, and it's more used for even the it's just a 60 things you can be used many types and more like a social marketing education such each software they have their own customer target customers. The econometrics are you have been aware of this. Econometrics is something like a theoretical is what do you call it? Uh, practice like demand theory. Demand theory is you're going to experience like how it is really working or something is different. So you have been what all the theories are put into the reality and the economics like there will be a description like a data sets there it is defined as a let me explain that also. They're like a time series data, cross-sectional data, and panel data. This way it has been described about data sets or related to the time data cross-sectional and the panel data analysis you can do with the help of econometrics. And today we are talking about analysis. So before the statistical inferences is a statistics which is concerned with using probability concept deal with a certainty decision making. What is it? You've been drawing the sample and you've been conducting control. So drawing the control data very precise and accurate. You can see that anxiety between that is what the event, right? It is it is a, the position is something like the the actors is is more scattered or somewhere it is scattered. That may not be the right way you can make a decisions. So it is very important how you draw this inferences about the population which is sample done. There is a sampling distribution, central limit theorem, point estimations, interval estimations, confidence interval, degrees of freedom, confidence interval with for mu, and confidence interval for the proportions. All those things which related to statistics. We are all aware of this because we have experience with how to draw the sample and how to conduct how to what to say, because once you set the sampling methods, the sampling technique, proceeding further, right? Sir, is it visible now, sir? Is it visible, sir?
Yes, sir. The slide set. We are seeing the slide 6 now, right now. Sixth slide right now is on the
Slide
display.
6, sir.
Yes, sir.
Slide 6. Okay, okay. I'm moving to slide 11, sir. Okay, 1 minute, sir. It's only you've been seeing. Okay. Um,
And also, your voice is muffled, sir. I think you could move a bit to better network connectivity area, so we could hear
okay,
you.
1 minute. Okay, so 1 minute, sir. I'll try, sir. Hello, sir. Is it now just fine, sir? I think is there any break? Hello, sir.
Um, it's reduced, sir, but we can hear you. Let's see, sir. You just continue. We'll hear you out.
Okay, where is that, sir? Right now, where is that, sir? Slide,
Slide
which
is on the sixth slide, sir. It is not changing.
it's not getting changed. Okay, 11, sir. I'm moving to 11. 1 minute, sir.
Sir, 1 minute. Let me show you an option, sir. I think it will help you out.
Yeah, sir.
Just 1 minute. I hope you can see my screen, sir, right now. It's the meeting
1 minute,
screen.
sir. 1 minute, sir. Yes, sir.
And this is the icon where you will be clicking to share your
No, no, sir. I'm not able to see this. Sorry, sir. It's
mic.
something is no, sir.
So could you mail me your PowerPoint presentation, sir? I will share on my behalf. So it will be easy to transmit.
Okay, sir. Very nice, sir. That is fine.
You can mail to hod.microbiology@ratnam.in.
1 minute, sir. I'll just. HOD. HOD, sir.
Dot microbiology at
At microbiology, sir.
HOD dot microbiology at ratnam.in.
Miss biology. Ratnam. Sir, Ratnam?
Ratnam.in.
Yeah, okay, sir. I'm sending, sir. Okay, sir. Sir, I'll try, sir. One more time, try. So I'm not going to share, sir, because the sharing is an issue, sir. I think,
You
sir.
may continue the session, sir. Once receiving the PPT, I will share on my behalf. Not an issue.
Yeah, okay. So is it reaches to you, sir? Is it reaches to you? Hello?
No, sir. I have not yet received.
Sir? Yes, and sir, I think.
Not yet received, sir.
Still uploading. Yes, sir, it is sent, sir. I'm sharing the screen, sir. Is it visible, sir? Hello, sir.
It's getting
Hello.
loaded. It's getting loaded.
Sir, I will not make any screen share, sir, because, sorry, this one, a slideshow, sir. There is a lot of issue in this slideshow, sir.
Sir, I have received your PowerPoint. Please wait for 1 minute. I will share it, sir.
Okay.
So you can stop sharing it.
Okay, I can. I'll stop, sir. And stop. I stopped, sir. Yes. Sir, are you?
1
Yes, sir. Sir.
Can you see?
Yes, sir. Yes, sir. I can able to see, sir. Yes, sir. Great, sir.
On.
Can you move to 11th slide, sir?
Comments.
Yes, sir. Sir? Hello, sir? So, Srinivasan, sir?
1 minute, sir. I'm having a technical issue right now.
Okay.
Nothing more, just 1 minute.
Yes. So, I think next I'll move because since it is technical glitch, anyway, I'll be continuing with this, whatever I want to explain. Hope it won't be without PPT, we can visualize things. So test of hypothesis, you've been aware of this. Test of hypothesis, like we have been proposing the tentative statement in front of the any uh, research items that we make. Like we are having the binary answers like a yes or no. Similarly, here taking a binary, here it is like a null hypothesis and the alternate hypothesis that we have been proposing in front of the testing and hypothesis. That is what actually the hypothesis. The hypothesis meaning you can be make it as a tentative statement or the researcher's assumption, anything that you can be whatever your proposed statement. That is a binary way, that is null and alternate. Null is always stating this no difference, no associations, what do you call it? No correlations. Like which it will be the which says the how much is the it is in binary way. There is no that is what here the null that meaning, and the alternate will be the alternate one, which is like a one. That's what we always specifically mention, that the zero is a null hypothesis and alternate is a one. And if you see that the type 1 error and type 2 error, so like a hypothesis, like a investigation and the presumptions is the presumption which is taken. I think you have been aware of this, the criterion we set in the accepting the null hypothesis and the rejecting the null hypothesis. Like we propose the acceptance reasons, like 5% significance, 1% significance. We set a criterion, and from there we propose. So if beyond this level, and we reject the null hypothesis. So we call it as the one-sided and two-sided, otherwise called as left-sided, right-sided, and the two-sided, both sided. Next, sir. And null hypothesis, it is always you have to be the test which is rejects. There will be a type 1 error and type 2 error. That will be the combination which you can see here. Null hypothesis is true, but our test rejects it. Test rejects it. The null hypothesis false, our test is accepts it. The null hypothesis is true or test accepts it. And the null hypothesis false, but our test is rejects. What is that? Our decision is we have been, so when it is null hypothesis is we have been proposing null hypothesis, that statistically it says that true, but we are accepting also the true. It is the what you call, we have been null hypothesis accepting, then there is will not be any things. We have been taking the alternative decision like rejecting, that is a wrong, that is called as the type 1 error. Similarly we called as this, so I will just make a use of the box which is the next slide. Next slide. Yeah, you can able to see that the type 1 error and type 2 error, that is an h not true, then accepting the h not, it is the right decisions. You don't have any kind of the corrections required here. And the when your type h not is true, but you have been rejecting the h not, which it is called as the type 1 error. We can define as an alpha in the technically we say that it is an alpha, in otherwise we call it as the, and it is a producer's risk. Why it is producer risk? Let me explain. H naught is false, but accepting the H naught. H naught is false, but accepting the H naught, which means there is a differences. But you have been accepting the H naught, that which you have been proposing, there is no difference. And when it is false, you have been rejecting. It is right decision. So right decision, it won't be a any kind of a error that brings. But an type 1 error and type 2 error. Type 1 errors denotes as an alpha and type 2 errors in beta. Type 1 error, we call it as the consumer risk, as I said, and the type 2 errors in the consumer risk. Why? Because, for example, I can make a statement here. Like you are as a quality inspectors, you have been seeing in the mass production area. Suppose you are like a production of this mask, the mask productions. And the daily basis 10 lakhs volume and 1 crore, 10 lakhs volume you have been producing. So you have been testing that whether it is rightly, it has been fitted all the areas and it is covered rightly. You have been checking that. So you randomly pick 10 to 15. You have been randomly pick and test. You have been saying that, okay, there is a rejection, there is a condition which 1%. Let's take um, 10. We have to take as a sample. One has to be get one it is, can be get defective, and 9 should be the past what do you call it, the positive one. That's why you have been randomly picked. Now you have been seeing that the one is you have been taken the 10. Out of this, one is the defective. Then you don't, you can say that, okay, no defective, you can go for the next batch process, like you can dispatch that. Suppose if you are getting a two as the defective, like a company policy, the 2 is there, you have to reject the entire lot. In this condition, you have been further processing. So you have been allowing, no, no, might be the my sampling methods might be different. That's the reason I've been allowing to go for the dispatch. That's what it's called, producer risk. And the consumer risk, there is a difference, which is you find that there is a difference. But thing is, you have been allowing that there is a difference. So the consumer risk, like only one is defective, but you have been rejecting the entire lot. That is called the consumer producer's risk, because even though it is fitting into the criterion, like only one is data defective, but you're saying that you're advocating that my sampling method is not appropriate. That's the reason I'm getting only one. Otherwise, I've been chances more defective. That's the reason I've been completely rejected lot. That is called producer risk. Consumer risk, there is a difference. There'll be two defects. The mask you have been getting, but you have been anyway. You've been telling that my sampling method is wrong, but it is. I've been approving that the go for the next production. It is called as the consumer. That's just an example I've been making so that we can understand. P value, we have been most of the time we have been deriving on the p value, depending on the p value to take a decision. See, p value is nothing. The p probability of committing type 1 error is called p value. The p value is the chance of presence. The difference concluding with the actual is the p values can be defined as 0.05, the 5% or 1% significant. P value is one is the highly significant. They're called as highly significant. We generally prefer the 5% because science and other studies, they go for the lesser than because they're what do you call the significant level, the fitter is little high in the sense only allowed 1%, less than 1% they keep. The power of test, like the power of test we have been using in the statistical difference, we have been taking the statistical difference. It is a probability to trial which is 1 minus the probability of type 2 errors, called as the power of test. It is nothing but the 1 minus beta. So next, I think you have to understand the p-value calculation. The p-values are less than 0.05, which means your proposed null hypothesis, you can be rejected. Otherwise, you have to accept the null hypothesis. That is what the criterion says. I said it is upper tail test and lower tail test. It is like a negative and positive. That is left tail and right tail. You can make as in any kind of a criterions. You can be fixed up. So next, sir. Next. And this is very interesting. So what kind of a test we have to propose? So it depends upon the data structure. We can propose the which test we can be proposed. Like based on the specific distribution, such as the Gaussian normal distribution, you can be proposed your test like in a social science, which is very popular test like a t-test, one sample, two sample, and per t-test we can use. Z-test we can use. ANOVA or F-test we can use. Pearson correlation that we can use when it is normally distributed. Not based on any particular parameter such as the mean, so it does not follow any kind of the Gaussian distributions. We have to use the other test like something which is a sign test and chi-square test, ANOVA, Kruskal-Wallis test. These are the tests which we use. The upper one, this Just an example I have been kept here. Apart from that, many tests which fits for the when the data is normally distributed and not normally distributed. You can keep this, but the test which will be popularly used in a social science that have been kept, and this denote as the parametric and non-parametric. That means it is followed by the Gaussian distribution. It is called as the parametric test. Otherwise, it is called as the non-parametric test. See how you can be select the test. So the how you can be select the test. The t test you can be compare what you have been, the why we have been conducting this comparison of two independent groups. The t test independent samples when it is standard deviation is unknown. We can use the parametric test. You have to define that whether the parametric or non-parametric. Based on that, you have to propose the applications you have to choose. And non-parametric test, you like to compare the two independent groups, the alternatives, and the when your data sets falls under the non-parametric, you have to use Wilson rank sum test, man between you test that you can use. And when you like to purpose of your application, test the difference between the bird observation. You can pair the observations. See, like a pairing two events like a division 1 and division 2 sales, and or otherwise something like a before and after scenario you like to test. Then during that phase of time you can call it as the pairing. The single the event is unique, like before and after the attempting the test. So before going a training, after going a training, how much is the productivity increase in the organizations. That also that all you can be you can be tested through the pairing. The event is here the productivity. So before and after is an event you've been setting. And Wilks and signed rank test you can use an alternative manner in the non-parametric. The comparison of several groups, you can make it as several groups like a ANOVA has been used when you set up the like a, we have a group like a teachers, like engineering teachers are there, science students, science teachers are there, commerce teachers are there, arts teachers are there. We have this who is having the stress level more, or which kind of a combination there are how many, so their stress level I can be seen that are working hours, the preparation of hours, the class, who's doing that I can see. I can if I have a combination of the many four faculty groups, I can see that which is there any differences? I can find out is there any differences among the groups which have been taken, or no, they follow the same. So we can find out that because in the ANOVA will tells that the it's a basic medium that find out that how much is the differences there, whether the difference is there. That information that tells us what kind. We can go for this other test like why the differences arise. When it is explaining to us there is a difference, the stress level is different. Engineering teachers and science teachers and other arts teachers, there is a stress level is different. We can find out that why that is a difference. You can go for the researches what is basically serving like a 5W1H. You have been aware of this 5W1H, like it is answering to the all the 5W, like when, what, where, and similarly the how. This 5W1H is going to be served as the best answers. That is what actually a research. And next is the quantify the linear relationship. The linear relationship, you're going to use the correlation, that pattern you're going to use. And only things, the previous slides are one. The previous slides. The previous slides, sir. Sir. Oh, sir. Oh, no, sir. Previous slide, sir. Previous, yes, sir. The association, the quantified linear relationship, it is a Pearson correlation, the Spearman rank correlation. That is the parametric. You can follow the Pearson correlations, and when it is non-parametric, you can use the Spearman rank correlations. And next is the test, the association between the two qualitative variables. You have been aware of this. What is the two qualitative variables? Like there is a definitions against the category of especially at the primary data collections. You've been assigned the cat. You define that actually like next. Let me explain. So next. Yeah. So measurement and scales and various types. You can understand the categorical. What is the categorical? Nominal, ordinal, interval, and ratio. These are the measurement scales. In the data types are categorical and the measurement. What is the difference? The categorical and the measurement. Then, like, is like the natural categories, just a male and female, just natural category. And what you see that we make it like qualifications, like PG, UG. We are not having a particular about the which domain they're specialized or they graduated. Then we are not keeping that information. We just kept what is their qualifications. Are they graduated? Are they postgraduated? What are their highest qualifications? That way we take that and we plot the category. So how many are we have taken 150 samples, and out of that, how many are PG? How many are UG? Like this, we have been classified to make a category there. That's called it's called the categorical. So it comes under the nominal data. We ourselves make a classifications. We ourselves make a classification that is called the nominal data. Like for example, age. Age you have been plotted like so for the easy class understanding, you have been making a classification like 15 to 20, 20 to 25. Like you make uh, a category so that you can be fitted the how many numbers are this category, how many numbers in this particular category, so that it is easy for you to go further, because something like you need not to verify the 2021 like so you need not to keep the data which is the actual. When it is, what is the difference between the actual and the categorical? The categorical something like we keep like we make the classifications, we ourselves make a category, then it has become a categorical, that is nominal. Otherwise it is not, no, it is an observations like a actual observation. For example, age, if I'm not keeping an actual observations, then it become a, it's a number, like a measurement, the quality quantitative. But when I'm keeping like a setting a category like 15 to 20, 20 to 25, and there I am fitting the what is your age, then it becomes the nominal data. That is the difference you have to understand. When the actual data numbers, for example, similarly I've been fitting the income, I taken an income. What is your income, annual income? I make it here, the taken the actual income have been recorded, then it is quantitative. Suppose I've been feeding the scale, the something like a category that you're trying to make 1 lakh to 20 lakh, 2 lakh 50,000, 2 lakh, 3 lakh to 5 lakhs. Something I've been make a category, becomes the categorical. Ordinal you can understand. Ordinal something like there is an order, and moreover the nominal we categorize like any of the order. Like here the number which is assigned the each category up to your own convenience, like 1, 2, 3, 4, 5, anything that you can be quantified which are each category. It doesn't have any kind of that differences. But whereas the ordinal, it has the it wants in a distance, like a first rank, second rank. First rank is the who's having a superior, who's reached the superior level. They call as the first rank. Second rank would be the second highest person, or second next to the first rank person, which is called as the second rank. Here the number which is assigned each category, first rank, second rank, third rank. The like a priority. Suppose I've been asking you, which is the first priority? The first priority, like quality, food quality. The restaurants, I've been asking that. How do you rate the restaurants? Like a food quality is the first preference, which means first it is considered the highest important factors among the defined variables. And the next is the interval. Interval, you have been aware of that. There is a distance. What is the characteristics of the interval? Interval is an equal distance equal distance. It means, so for example, 10 to 20, 21 to 30, 31 to 40. Like there is a equal distance you have been followed, like that's called the interval, and the ratios you have been arriving that the ratio is something. So next slide, sir, I'll be explaining. So intervals, the places, objectives, order in equal differences in value denote the equal differential that we are measuring. The ratio is the similar interval measurement, but also the true 0 point. You can divide the values. 24.1 seconds, like I've been creating that. You can be divide that. That is what the ratio is here. Ratio. So, but in any softwares, it has been defined like a nominal, ordinal, and the directly it is you can be taken as a interval ratio is considering one element. There is no much distinction in the interval ratio. We're considering the SPSS software. So next, sir. And parametric and non-parametric, I told you that it is you have been measuring the which way. How do I conclude that whether my data is plotting under the uh, parametric or non-parametric? You can use the diagram, which is there are the specific diagrams which we can use. Histograms we use, it will express to you whether your data is uh, nominal distributions, or it is not falls under the normally distributed. It can be mentioned that. So like so next slide, sir. So you can see that this is the skewness. The skewness test will be say that this is the right skewness and the left skewness, where the data are overloaded in the right side. The data are overloaded in the left side. That's called as the non-parametrics. So this left skewness, negative skewness, and the positive skewness that you can understand. Like there are three properties. The data are normally distributed, that is skewed. The data is homogeneity of variances. There is a in the data sets you can mention that there is a problem with the homogeneity and the heterogeneity. There are sometimes the cluster groups are the numbers are very close to each other. That is called as the homogeneity things. And the heterogeneity. Heterogeneity means the variance. You can have the huge variance, which you can see that there will be a that's the reason you can the homoscedasticity problem and heteroscedasticity problem we have been observing in the each level, and especially the when you have the time series data, we used to do that. Okay, next. So next slide. So next slide, sir. Next slide, sir. Sir, next slide, sir. Srinivasan, sir.
Sir, I'm
Yes.
changing one slide at a time. Just go with the topic, sir. Let me know which topic is correct.
Okay, sir. Which okay, 24th slide, sir. 24th slide, sir. Non-parametric test, sir. 24th slide, sir. Yes, sir. You can change to the 25th, sir. Yes, sir. So you can see that the normality, the how is this normally distributed. You can able to see that this is an histogram, a diagram, which you can be plot this, and more or less it has been. You can see that the normally distributed. The group which is assigned here, which like a normally distributed, your numbers are grouped here and through the histogram, and you can be called as this is the normal. You can declare that this is the parametric. So next, sir. Next slide. Next slide, sir. Sir? Yes, sir. Yes, sir. When the parametric, which is non-parametric, you can see that like the histogram which is plotted, but thing is data is more or less equal, but you cannot declare this is the parametric one. You can declare this is a non-parametric one. You have to go for the non-parametric test. So if you're applying in the parametric, what will happen? So whatever you have been drawing the conclusions, that may not be right. That's what you can be, that's the reason you have been choosing the right tools with the help of the parametric and non-parametric. Next. Yes, you can see that the normal plus outlays completely outlays. This is also will be the numbers which you can see that few numbers is been plotted in the right side. It is starting from the extremely in the right side, which is this is the, even though it is plotted like a normally distributed, but few numbers you have been it is plotted in the right side. Either you can be these conditions, if you are comfortable with this data, you can be ignore this data. This is what called as the cleaning of your data. One or two numbers you have been extremely in the other way, so you can be remove or you can be reconsider. So that data you can be, since you have been completely satisfied with this pattern, so you can consider this uh, parametric, consider as a parametric if you want to remove this data. So you need to clean the data, something like a data it's not accurate, or sometimes it is we make an error, but might be that reason it is getting, or otherwise you have been comfort going for as per the system at the statistical test. So this will lies under the non-parametric. This is what it says. So next, sir. The next, sir. Yeah. So once again, I'll recap that, which is whatever it is used like a there is a normal which is higher variances and lower variances also, and then you can see that depends upon the test that you have been using, depends upon what whether it is a lies on the parametric or the non-parametric. That is very important. Then only it is satisfied that level, you can choose the appropriate statistical tools. I've been given the idea, you like to compare the means, or what is your actually a purpose to taken the test, serving the test. Based on that, the test selection also you can do that. So see what is the idea here. Rightly you can take a data, and data has to be validated in the right way with the statistical, like using the histogram you can be defined that where it falls, whether it is parametric or non-parametric, and then you can proceed like a selection of the tools. This is what the procedural way you can be taken the test selections. And the second same, this is what actually I want to explain, the equal test, which is the parametric and non-parametric sides. The Pearson correlation in the non-parametric side, it is Spearman correlations. No equivalent test in the parametric side, which is the chi-square test. Like a chi-square test is very important test. It's just like what you say, it is the association, especially wanted to see that the goodness of fit and associations. You can use that the chi-square test. The chi-square test is actually uh, checking the associations with the two qualitative variables. Like two qualitative variables is nothing but the categorical variables. You can understand the categorical and the measurement. Like sometimes the people are asking that the sir, is it a Likert scale comes under the scale? The yes, Likert scale comes under the measurement. Why? Because Likert scale as uniform way. Uniform way is it has been set like five is an strongly agree and one is that strongly disagree. This way it has been having a uniform measurement. Like wherever you go, the same measurement is followed. That is called as the measurement. I hope you understand. Like 1 kg, one everywhere wherever you go, that is the same setup you have been followed. Like that is called as the measurement. Like a second thing which you need to understand, like arbitrary scaling look like a scaling that may not be a scaling. Like for example, you have been rated yourself like a good, average, bad. Likewise, you have been feeding this scaling, but this scaling is called as the arbitrary scaling. It's not a real scaling. You have to understand that. Yeah, because the scaling means it has to be uniformly measured the same, uniformly defined the same. And the dependent means t-test, Wilson t-test. One way independent measures, which is the analysis of variance. It can be equal test, which is available in the non-parametric side. Driscoll Ballis test, and one way and repeated measures ANOVA you can use in the parametric side. The Friedman test is available in the non-parametrics. So equivalent test has been developed both the side because the data isn't concerned. But thing is there are the equivalent test is already defined. But only thing is the idea gets different. But there is an idea gets different in the sense the hypothesis, the idea mathematically the idea it differs. How what is the proposing in the parametric may not be in the same may not be followed in the non-parametric. So next, sir. Nominal, you can use the nominal data. See, very important. You can choose the nominal means you can use the chi-square test as in when you're having a two into two table which like two distributions like age along with your with your qualification, something like have an opinion like a arbitrary opinion. So like a good, bad, average, or oppositions. Like I'll give this examples, all those things. That there you can use the chi-square test in the example, like a qualitative and qualitative. This way you can use the chi-square test because there is no alternative in the parametric side like equivalent as a chi-square test. So next, sir. The ordinal, I think Spearman correlations, all those things we can ignore, sir. It has already been explained. So next, sir, next. Yeah, t-test. I'll be using showing the t-test. What is the t-test? There's an assumption it is that two groups must be independent. The scores in each population must be normally distributed, and the population must be equal variances. That is what the very important. Right? You need to be check the p-value as the lowest the significance of it, we can reject the null hypothesis. Always we have to set the null hypothesis like in using this kind of a t-test. Starting with that, this all comes under the testing of your hypothesis. I told you that the meaning of the hypothesis, like you have been proposing an statement, tentative statement, like a null and the binary mode, like a yes or no conditions, null hypothesis and alternate hypothesis you've been proposing. Next, sir. Yeah, parametric test work is a scale data. You have to understand that the the scale means there is a uniform measurement, 100 marks, 20 marks. Like there is an marks has been quantified. You can say that. So, for example, even this it has a measurement like values you have been taken the actual one you can use in the t-test, one sample t-test, and the dependent related samples and the independent unrelated samples. These are the mechanisms we have been using in the t-test. So next, and the one sample t-test, you have been aware of this, the formula, which even the one sample test, you can be used the point like a Likert scale and terms of performance, you can be used the one sample t-test like a mean and comparison value divided by the standard error. The standard error you have been defined in the technical order like a sigma you have been using here, mean and the comparison value. Mean, it is nothing but the x bar, you have been aware of this. Comparing value, you have been set the comparison value, how much is the, you can set the target value here before proposing the hypothesis. Are they differ from, I can set and propose marks like I have student marks, 10 students are there, I set something like a 55 is the comparison value, all the students are 55 and they scored 55 or and above. That is what the stating the hypothesis here. The 55 is the target value. I've been comparing the value with the mean and the comparison value. I've been derived the conclusions whether my tested value, the target values are uh, is what do you call it? It is a which is a means are equal. I can say that means are equal or different. That way I can set. So even though if you are not having the comparison value, you can make a statement like means are equal or the difference. That way you can propose the hypothesis. So next, so standard errors, the standard errors, standard deviations divided by the root of n. So next, you can move sir. Next, these are the aware of this view. Okay, I'd like to mention that the output. This is an SPSS output. Like what is that our proposed hypothesis? Like you can able to understand the one sample statistics here. The mean value 3.400 and totally n is number of observations 5 and the standard deviation that we so you can able to see that the rating which is t-test, it lies on 7.884, the degrees of freedom 4, and then significant two tail it shows 0.477, which means here you can define that before going to this I can say mean values are 3.4400, standard deviations 1.1402. Like I can understand the standard deviations and the mean value. Like a simple example, in a class, two students are there. Their score in the A B. Let's take A scored 100, B scored 0, and comes to the this another class which is scored A is, the C is student C is scored at 50 and D is scored at 50. So in this combination, you see that class A, class 1 and class 2, class 1 average is 50 and class 2 average is also 50. Because you see that 100 divided by 2, two students are there, 50. And when you check that the another class which is 50-50, there is no the average is also here also 50. But how do you define that the both the class are equal when you see that in the average side? But apart from that, any other tools are there, because you see that one student secured 100, another students has secured 0 marks. If you define that both the class are efficiency are same, that is wrong. That is the case what you have to define. So you have to see that there is a standard deviations. Standard deviations tells that the whether is it an appropriate is low as much as low at the low standard deviations, low the high efficiency, the high accuracy. That is what the meaning of the standard deviations. Standard deviation you can see that 1.1402. So there is no, it is not much. So and also the result says that 4.77. What is the conclusion here? The test value, the means are equal. That is what the H naught. Means are not equal. That is what the H1. That is what the proposed hypothesis. What you can take as a whether you are going to reject the null hypothesis or they accept the null hypothesis. What you can take as since the p values, so this significant two tail, it's stating the p value. The p values here it is 0.477. 0.477. It is above the 0.05. In this conditions, we cannot reject the null hypothesis. We cannot reject the null hypothesis, which means the means are not equal. That means it is you can propose the things equal or means are equal. That is what you have to understand. Means are equal, not equal. That is the conditions. Yeah, we cannot reject the null hypothesis. We have been accepting the null hypothesis. So mostly we always propose the hypothesis, whatever the proposed hypothesis, we try to reject, which means that we'll say more uh, systematic, like what you say. Uh, that is what we always try. Uh, like there is a difference in the gender groups. There is a difference in the investment region A and investment region B. So if you are following the same, there is a you can what is that? It can the both are same or both are similar. That is the case. What is that? Uh, their attributes are said always there is an associations the investment attributes in the gender cases it is evidently we have seen and the many research it shows that there is a male and female attributes are different against the investment if I'm defining that the both are the same their approaches are same which means there are some lacking on collecting a data which may not be reaches to the right level to the while collecting a data and we have not structured the question right way of questions all the other reasons are there we have to go for this depends upon that's the reason we are while structuring the questions you should be very careful and what you have been collecting especially the social science research and the primary data collections you have to be very careful it, I'm not saying that you cannot be collect everything in one shot but thing is you cannot collect see the 100% real information but thing is whatever the questions you have been put up that has to make the sense and reaches to the respondents and the respondents has a, will invest a very quick time to understand the question it may not be a very like a very one statement is a huge statement to understand that may not be the right one so here you can see that if the p value says that I cannot reject the null hypothesis, I cannot able to reject the null hypothesis. This is what it says. So next, one sample and paired sample t-test that you have been experienced. I told you that the one sample t-test and the paired sample t-test, like a pairing and even like a productivity, like a before and after. Before training and after training, what was the productivity difference? Division A and division B. What is the difference? You can observe that. You can like a event could be the one, but you can check that before and after that phase. Before GST implementation, after GST implementation, before demonetizations, after demonetizations. What is the improvement? So you can also check all this narrations by PAT test. The pairing test that is what the very important it's very successful the people who check that the efficiency like even a small amount of efficiency especially in the science field also we can use the using the particular pesticides before pesticides use and after pesticide use what is the growth you can measure that okay daily basis the growth that base is it is a t statistics pairing test will helps to you. Next, next, sir. Sir, next. Sir, next. Sir. Sir? Yes. Patch sample test, you can see that the professional executes the salary difference. You can observe that, like 6 employees, and you can be see that the differences, chief executives and their salary differences. You can be observed that are they the salaries are same in the region wise or they different. You can be observed that. Okay, that is called as the batch sample test. You can make then one single event and you can find out that the salary is an event, and you can make as a two regions. The comparison we have been making as two regions. So next, so next, sir. The equal variances, like you can say that there are two ways to calculating the significance that under later samples. Which is equal variances are assumed that two sets of score approximately equal. Equal variances are not assumed. Like testing the equality, you have been using the variances 11 test. It is automatically calculated. Like what is it is fitted in the algorithms in the SPSS and other software which is customized, user friendly. That no need to worried about the what you call only thing you have been selecting a right tools. Okay, it may not be indicates to which tools it will be. Anyway, there is an ordinal while measure. If you are keeping the right measurement against the data, it will take whenever what you call suppose ordinal data cannot be used for the chi-square test, like a scale we cannot be used in the chi-square test. It will be simply it will be indicate to you, but at least you can know that before you proceed the test of selections you should aware of this what. And moreover some uh, formalities, the basic formalities, it has been understood by the statistical package softwares. You need not have that much procedures. So only thing is when you are having a chances to see that more itinerary, you can take that. Otherwise, need not to be worried about the fundamental assumptions. Fundamental assumption it will be taken in the automatically. For example, Z test and T test. Z test and T test, you can understand the difference. Z test something like a beyond the T test, it is less than 30 samples, and something like a beyond 30, it will be Z test we use. But we need not to be defined that the Z test or T test in the SPSS softwares and other softwares also, because it automatically consider when the sample size is more, it changed to the Z test. That is what it works in the algorithm sites work in the SPSS and other softwares. Next, so next, sir. And the chi-square test, very important. The chi-square test, people are using the chi-square test in the testing the independence and the goodness of fit. Testing the independence, which determines two or more observations across the two populations, dependent on each other. That is testing of for goodness fit with the determines observed frequency. What is that? The observed frequency and the expected frequency. There are the expected frequency which is derived through there is the format like you considering the rows and columns total and the grand total. This way we have been proceeding with the expected frequency, and moreover you can use the average as an average also is the expected frequency. It depends upon the which mode you like to measure the variations, the associations. So generally we go for the expected frequency, which is the row and column differences. So next, so chi-square test, you should understand the observation is recorded and collected on a random basis. All items in the sample must be independent. No group should be contained very few items say less than 5. Some statistician says 10. The number of items should be more than 50. Like you see that there are the condition which you have been using the test, which is the first conditions, which is the test cells value should be may not be less than 5. If it is less than 5, we have to use some other corrections. Let me explain that also. The chi-square distribution, not a symmetrical, and all the values are positive for each degree of freedom. And moreover, all the values are independent. You cannot be posted like what is the difference? Like independent means like see, for example, total 50 means 48 will be fitted value. 2 is the 2 is the 48 is the absolute value. 2 is the fitted value. So it cannot be like that. So all the values should be drawn from the independent manner. That is what actually get the understanding. So next, and this is the comparison comparing the variances like a small formula which is a sigma s square and sigma n minus 1. Let me explain that test of comparing variances. So yeah, so the chi-square test is non-parametric test of goodness of fit, test of independence. You have to go use for the chi-square. This is the symbol which is the chi symbol. So make it an x and a small like a crossing x is above the square, which is that is what the symbol of chi-square. And some are pronouncing at chai, and someone pronouncing at chi-square. I think it is up to that. I pronounce it at chi-square. It is. I hope it is not an issue. Sigma O minus E whole square divided by E. That is what the actual the formula. So we need to set the expected frequencies. Next, sir. So next, sir. Yes. Determination of the, if you are computing the individually, you can see the chi-square test O minus E whole square. The degrees of freedom also it comes R minus 1, C minus 1. Yeah. This is the expected frequency O minus E. Yes, sir. You can move, sir. Observed frequency and expected frequency divided by the expected frequency. Next, sir. So next,
Sir, can you see the slide?
yeah, no, sir. I'm able to see only the calendar, sir.
Now, sir.
No, sir. Still in the calendar side, sir. Yes, sir. Yes, sir. Can you move down, sir? Yes, done, sir. Expected frequency. Yes, sir. Great, sir. Down, sir. Down, sir. Next slide, sir. No, sir. Down, sir. Hello, sir. Next, sir. 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 Yeah. Expected frequency, which is row total into column total divided by grand total. I already told you that two variables are associated. You have to take that associated means there should be have a common relationship like a age and along with this particular expression of the some then let me explain what is that. For example, you have been taken that the party A and party B, their opinion, favorable oppositions are the neutral. That is called as the their standing. What is their standing positions and the party A and party B. That party A and party B are the categorical. Similarly, they are the order of preferences like positions are the favor or the neutral. They are standing. So both are we call it as the neutral. Sorry, categorical. The categorical we can go for the chi-square test. I told you that the both categorical variables x into y, then that is the case there is no alternative for the even though it is parametric test you should follow the non-parametric like a chi-square test only. So next sir. Uh, next sir. Yes, the next sir. The next sir. Yeah, next sir, you can move sir. This is in category critical values tables. Anyway, we are not going to use the tables. I told you that we are mostly moving on to the softwares. Software tells us to understand by the p-value. We are not going to use the critical values like what you define in the see. Suppose if you have been using but the p-values, it will be you'll get as a p-value. From the p-values only you have been taking it to set a decision making like whether it is null hypothesis rejected and accepted that you are going to do. So the manual feeding you have been looking on table value. From there you are going to see that the selection of accepting or rejection the null hypothesis. So next sir. Next sir. Yeah, we can see that the small description which is here the method as the manager you want to test the perception of the fairness of the methods. The 180 implies a 63 rated. Method 1 has been considering the 45 as rated and 272 and 3. So there he wants to test the perceptions. The method 1, method 2, method 3, which is the fairly good. So was the next slide, sir. Next slide, sir. Next slide, sir. Yeah, you can observe that the expected frequency you have been set it as an uniform basis, like the average 60, 60, 60, and you have been seeing that the 6.3 is the O minus E. That is O is minus E. E is we here the setter as the average, and we found this O minus E is 6.3. We 6.3. How we can conclude that whether the accepting and rejecting? We have to refer the tables value. That is what the manually we does. We does that. Sir, next sir, next sir. I think. Sir, next slide, sir. Sir, next slide, sir. Sir, next slide, sir. Sir, next, sir.
So can you see the slide?
No, sir. Still, yeah. No, sir. Only I can able to see the calendar, sir.
No, sir.
No, sir. Only. Yes, sir. Yes, sir. I can able to see, sir. Yeah. Suppose. Yeah. Yes, sir. Yes. The next slide, sir. You can move, sir. Next slide. Yeah. You can see that this is a bivariate. Earlier, it was not a bivariate. This is an that is an univariate. This is a bivariate. You can see that the party A and party B, their position like a favorable, neutral, and oppositions. The party A thinks that 10, totally 50 people out of this, 10 are voted as favor and 10 is in neutral and 10 is in opposing the the agenda which was proposed. Party B is 15 favorable and neutral is 15 and opposed is 10. So in this category, 90 is the total. So if you proceed like manually, what you get the results, which is even if you are proposing in the SPSS or Excel. Excel also you can get this. In Excel, how you have to do like a same the what is the difference? I'll be explaining in the SPSS where you can be plot this chi-square test, because in the non-parametric test there is a chi-square test is there, but that is a univariate. Individually, it will not have any kind of associations. Like where you have to get this chi-square test thing, that is an SPSS. There is an uh, this sorry analyze, the button will be there. I think hope you have been seen that. That's a case I have been explaining. Analyze and the descriptive, there is a cross tabs will be there. The cross tabs, in that cross tabs you can take the statistics. When you click on the, when you set this two variables, there is a statistics. You can select the statistics. The chi-square test will be there. The chi-square test you can be choose. That is the right way you can get the output. Okay, don't take that the non-parametric test and the legacy dialogues. Don't go that. That is not a right way of taking the chi-square test. Yeah, yeah. Please, sir. Next, sir. Next, sir. Next, sir. Yeah. So you can understand that the row frequency and the column frequency, you can understand that each total you have to draw, and then each based on the each total you can be get the outcome. So you can go faster. You can go faster because I'm stuck with this only two values. Yeah, yeah. We found this frequencies, which is the column frequencies. So yes, sir. You can go faster. Yeah, there is no. You can set the hypothesis. There is no difference between the A and B of the opinion on public issue. There is no association between responses, the public issue, the survey, the party members in the population. You can set here the associations. Okay, associations between A and B, their opinion, public issue. Alternative is associations. Anything. I've been used the word not difference. Actually, it is an associations. There is no associations. Okay. Next, sir. Next, sir. You found this. There's a how much is the expected frequency. There's an OS refers the observed and the expected is the C, which is E, which is the 13.9. Each columns, each cells you have to identify. Supposed to be 10 is to be favor in the party A column, but the thing is, what party A is under the favor, it is, but the expected frequency is 13.9. Like it, we have observed that. Okay, next, sir. Yes, sir. We can go in faster. We can. So next, sir, next. Yeah, we found that the x square, that is the chi-square, we found this 11.3. We have to refer the table values. I told you that table values are the referring, and we found that how much is the. But in the statistics, the SPSS, how you come to this only p values, the significant two-tailed. That is what you get. Pearson chi-square and what is the significant and the what is this sorry, what is the this they call the value, which is three values it has been derived, and the significant two tail value you have to see, and from there you have to conclude whether you can proceed, you can we can reject the null hypothesis or they accept the null hypothesis. Next, sir, next. So this is a degrees of freedom. I told you the degrees of freedom we are using R minus 1, C minus 1. Uh, the column which we see that R minus 1 is a row in row minus 1, column minus 1. This is what we are using, 2 minus 1 into 3 minus 1. We'll find out this 2 is the degrees of freedom. We have to check with the table value. We'll find out that the table value. So this is the manual feeding. And but before that, we have to understand the manual feeding. That's the reason I've been explaining. Anyway, you can do it in SPSS since I'm not getting a chance to show the SPSS. Yes, sir. Next, sir. Next, sir. So statistical values shows that the critical values, the table values are 5.9 and 1. We test the statistics. We calculated values are 11.3. What we can do this, null hypothesis can be rejected, which says that party A and party B differ significantly in their opinions and public issues. That way you can be controlled. But this is very powerful tools, which is the chi-square tools along that it is easy to proceed, give the conclusions and they're proposing any hypothesis, like especially on the qualitative uh, research. Qualitative research you can use the more in terms of chi-square test. This is itself explained to you because that is what we want. The party A and B are different from their opinion, or they're following the same. So why they're the difference that we can have another dialects. Thing is there having a difference? That is the first information we verify when you proceed further. In what context the difference and why they're getting a difference. That we can go for the further studies. That is what actually the each results will tells us. Yeah, next sir. Yeah, this is similar like this is like a Diet Coke. There's no one yes, it's just a yes. Diet Coke, Diet Pepsi. You've been taking that 286 customers. What you've been preferred that whether Diet Coke or Diet Pepsi. Yes or no? That context we have been using. So next, fast. Yeah. So we have understood that. Yeah. So next, sir, you can proceed, sir. You can proceed, sir. So it shows that 54.29, it is an independent solution which no relationship as the relationship. The statistics chi-square is 54.29. We can there is an evidence of a relationship. It shows that there is an evidence of a relationship. There is no relationship. So since the chi-square test statistics is huge, that's Pepsi Diet and Pepsi Coke has a. So this is a small the chi-square output, which is the Never and Catholic, which is a sociology study which is conducting the region 256 people surveyed in the marital status, like a diverse and their related religions, and it shows that the test statistics, chi-square test, you can able to see that the chi-square test it has probability p value. You can see that the p value 0.110, which means what? It is more than 0.05. It is, you have to see that in the manually and computer tells the results. Computer always you have to be stand in one direction. This p value, the probability of committing and typo error. That is what actually the p value. So p values will tells that it is less than 0.05. You can reject the null hypothesis. Otherwise, you cannot reject the null hypothesis. This is what it explains. So what does it says? Now it says you cannot reject the null hypothesis. There is no statistically significant difference between the marital status and the religions what they followed. Yes, sir. Next, sir. So next, yes. So this all I'll be making here the quick. So next, sir, we'll make faster because we don't have time. Okay, next. So we go. I think we can make faster because next is ANOVA. We have to go, sir. Okay. So kindly go for ANOVA, sir. I think one more thing which is I like to explain. There is a statistical correction will be there. One of the agenda which is in a chi-square test using like each cell value should be 5. If you are not getting the 5, what you have to do, you have to use the Yachts corrections, continuity correction will be there. Neckmas test is there. That it automatically nowadays it is robust techniques they have been using. If anything, the cells value, it gives the two-way. So before using the test, which is the corrections, Yachts corrections. After the Yachts correction, is there any significant values are getting changed? That way it gives. Okay, you have to, and you can get these two results, the SPSS side and other whatever the softwares that you have been using. You get that both the side. Okay. ANOVA, quickly this the ANOVA. What is the ANOVA? You have been analyzing the variances and the two quantitative populations. Like you can see that they take a this measurement is measurement in all the measurement, like a stress level you can make an index, like the salary level of which faculties are getting more, receiving the more salary. You can propose the hypothesis like engineering faculties, science faculties, or commerce faculties, the salary with their experience, 5 years experience, 10 years experience, with their you have been combinations, like you are seeing that how the salary structures are aligned. Is there having a difference, or that you have been observed any difference? You can conclude that it is there is a difference or not having a difference. So next, so it is actually a one-way ANOVA and two-way ANOVA and three-way ANOVA. That let me explain what is one-way ANOVA, two-way ANOVA, and three-way also. You can try to explain what is that one-way ANOVA. Just you've been taking the age and the BMI, body mass index, that you've been your age and the body mass index. You've been correlating. So you've been seeing that it is one-way ANOVA, and the two-way ANOVA, age and the height and the BMI. So you have been taking a two variables, two factors, and uh, testing that the your build an ANOVA, which is called two-way ANOVA. Three-way ANOVA is just effect of age, height, and the diet on the BMI. All the three you've been measuring. This like you've been taking the little more variables to connect with your the factors. The factors you've been adding more factors, and you've been testing with the one particular effects. So one-way ANOVA, sir. Next, sir. Sir, first, sir. One-way ANOVA. So you can change, sir. You can change, sir. Sorry. Yeah, one-way ANOVA. So what you need to have this, like you should have the normality and the homogeneous one, and then only you can do proceed. Normality has to be followed. And next, sir. Next. Normality and then homogeneity. Yes, this is the yes, sir. No problem, sir. Next, sir. Independence of error. Next, sir. You can measure the skewness by referring skewness, quarter size, Shapley-Wilks test. All those things you can measure through this assumption, like a normality test. Normality condition you can measure apart from that. Okay, this is just an observation, like variables which is how you manually fit it, like how you can find out this where what is the ANOVA. So ANOVA you can get taking an three observations like x1 and x2 relating to one particular factors. You have to understand that the factor and the variables are stating by representing one items, like a demographic variable, demographic factors, age, gender, qualifications, all comprising and one factors. So you have to understand the factors and the variables. Each factor might have the different variables. You have been experienced that because people might be experienced with the structural equation modeling and the highest modeling. People might know that what is these factors and the variables. So next. Yeah, see this the test which is next. One way ANOVA, anyway, people are used. I like to mention the two-way ANOVA. Sir, you can go, sir. Two-way ANOVA. What you have to use? Two independent variables. Like one is the categorical, another one is the scale. This way, you will get an output like this. Look at this. That does the private health insurance visit the physician more frequently than the people with the no insurance, other or other types of insurance? Like you can see that the types of insurance relating to the no insurance, private insurance, the star insurance, and the gender, male and female, this category. So one category we have been holding, and the number of visits relating to the three different designation. One is the no insurance, private insurance, and the star insurance. Are they differentiating? Are they getting any kind of difference? How this proportions will be happens in the uh, one way ANOVA and two way ANOVA. One way ANOVA is generally it will having a same groups like a X1, X2, X3, X4, which is having a one descriptions like a body mass index of the different people, uh, a different age group, different centers. So, like a B, C centers, like a city A, city B, city C, it is representing the same body mass index of each centers. Is called as here X1, X2, X3, X4. It can be expanded. You can see that the hypothesis. You can propose the hypothesis. There is no difference between the. There is no difference between body mass index of among the different cities. There is a difference between the body mass index in the among the different cities. Likewise, you can propose the hypothesis against the each category. That is what the one way ANOVA. The two way ANOVA concern, you can see that you are taking one categorical and the number of visits it's taking type of insurance, private insurance, star insurance, number of visits there visits been taken. One is the scale, another one is the categorical. That you have to remember that two way ANOVA, one should be the categorical, one should be uh, the things like yes, yes, sir, yes. So I think previous one, sir, previous one, sir, previous one, sir, previous one, sir. That was a stable, yeah, previous one, sir. Yeah. So what you will get, I think I will explain this factor one, factor B, and the interactions. What you will get an outcome here in the two-way ANOVA, factor A. Let's take in the previous example, age, and age is the factor one. The types of insurance visits the hospital. That is the factor two. The factor A is considering the male and female as the variable. The factor B is considering the visits under the no insurance, star insurance, and the private insurance. That is what the category. And the interactions. Let me explain one by one. So in the two-way ANOVA, you can keep the three hypotheses. First, you have been uh, checking the differences between the male and female, because here the factor A you can take as a gender. You have been proposing the hypothesis there is no significant difference between the male and female who visits the insurance, that is the visits the hospital, number of times visit the hospitals. The second factor two, it is understood that the factor B, what is talking about? Factor B, it is talking about the number of times visits by the each category of the insurance carriers, like a no insurance, uh, private insurance, and the star insurance. So there is no distinction. There is no difference among the insurance insurance users and the number of times, usage. So that is what the second hypothesis. Third hypothesis, like an interaction. This is very important. This is factor A and factor B. Factor A and factor B you have been going to be discussed. That is called as the interactions. The interactions is called as the factor A and the factor B. Like factor A is what is defined. Factor A is defined as a age. Factor B is defined the number of visits times with uh, the 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 insurance takers. Like you have been comparing. So three hypotheses you have been proposing. The first will be tells that is there any differences among the age category, male and female. Second, it is the among the three different categories of the insurers. And third one will be very important, A and B. It tells the A and B. This is very important. This two-way ANOVA only talks about the interactions, whereas the one-way ANOVA is not talking about the interactions. The two-way ANOVA is talking about the interaction. Interaction is a very good the outcomes, which is factor A1 and factor B, that is the having a is there having a difference. That should be very important. It should, if it is having a differences, then it will have more easy to make a segment, because always there will not be any uh, what you call homogeneity. Sometimes the opinion is always differ. The each categories, like a number of times visitors, always there will be a there. Sometimes it may be uh, the matching with the what you call the you'll false the there is no differences, but majority of the time you will feel that sorry, you find out that there is a differences. That is what actually the interaction tells, that interaction results will actually helps to propose to propose the hypothesis. The very important hypothesis here, the interactions A and B, factor A and B. So next slide. So next, yeah. So this is what actually, yeah, MANOVA is a multivariate analysis of variances. And yes, sir, yes, sir. You can proceed, sir. You can proceed, sir. Yeah, you can proceed, sir. Next slide, sir. MANOVA is actually when you can use that when two or more dependent variables. Generally, we'll have a dependent variables are one. When you are keeping the more dependent variables, then that is a scenario you can use the MANOVA, many dependent variables. That is actually it is more than one. It is fine. Not keeping more dependent variables. It is not advisable to keeping five dependent variables. It is not if so effective. At least one, two you can keep, two, three. That's maximum. But two is fine. Two dependent variables. If there's more than, if you want to disclose, you want to establish a relationship with the two dependent variables, then it is fine. You have been understood that what is the dependent variables and the independent variables. Hope you're aware of this. Independent variables, sometimes there is a, in economics there would not be followed by the which is the independent, which is the dependent. It's very difficult. So for example, inflations and the money supply, it is completely correlated. What is the inflations depends upon the inflation, the money supply will be gets, which is the causing factors, which is the dependent factors. Inflation, because the uh, inflation is the causing factors, or the money supply is the causing factors. You can find out that. So sometimes uh, which is a causing factors, which is the effect factors. You'll understand that. Yeah, sometimes the relationship like sales in narrate the profit. Sales amount will be narrate the profit. Depends upon the sales, then profit percentage will be determines. Always the sales is complete. The profit is completely depending on the sales. Yeah. Next, sir. Next, sir. It is a joint distribution, which is MANOVA, which gives the question, which is joint distribution. Two or more dependent variables significantly related, one or two more factors. That is what actually here the MANOVA uses. Yes, sir. MANOVA simply tells that the difference exists across the group. Such information, which is ANOVA, like a post-hoc test, we generally does. Like when sometimes we propose the hypothesis why that there is a lacking, or why we are not able to find out that something like a post-hoc test. Also, we have been doing with the help of the MANOVA test. We proposed something like here, like gender and the satisfaction with the facility provided, number of visits. So like more dependent variable you have been adding up, then you'll have the, you need to find out that dependent variables you can find out, because generally y equal to a plus bx, you can add up more x variables. Equal to a plus bx1, bx2. Likewise, you can add a number of independent variables, but dependent variables comes to that, it is very difficult to narrate or establish equations here. That is what an idea. So when you propose the too many dependent variables, it is very difficult. Yeah, next. This is fine, sir. This is fine, sir. Next, sir. Next. ANOVA, that is analysis of covariances. Something like a covariances, you can be understand. The covariances, you can understand what are the variances and the covariances. We are taking in two variables. We see that the variances among the each. So individual variances is fine. Among the two factors, we have been loaded factors. we see that the variances among the each age, that is called as the covariances. We have been using the covariances. We find out the beta calculation. For we have been aware of this, the beta calculation we does in the finance, the like covariances we usually find out, and the between the x and y. X is the individual data sets, and the y is the market data sets. Yes, yes, sir. I'm not going to detail talking about this. One more, it's a very important topic, so I'll be covering within 5 to 10 minutes, which is multivariate analysis. That's very important. That regression side, those who are doing the modeling. So that's the reason I wanted to explain that also. So next, sir, next, sir. Next. So next, sir. Hello, sir. Sir, next, sir. Sir.
Sir, I'm changing it, sir.
Yeah, straightly. Yeah, sir. It's yes, sir. I think it does move to the last. I think, sir. A little more. Yes. Yes, sir. Yes, sir. I think model building, from here I can start, sir. Hope you have been aware of this, the simple regressions, how you can propose as I said, generally you're using the function of what is the price is the function of what is that demand, am I right? So demand is the function, which is the price is established the relationship with the demand. It depends upon the price the chosen, or otherwise what would be the demand will be determined. Demand is the outcomes is function of price. Demand is the function of price, which means what? Price depends upon the amount of price increase or decreases. The demand will be estimated. Demand level will be get estimated. This is what it actually helps. So function here, which is derived. Hope you have been aware of the linear relationship y dx. So next, sir. Next, sir. So next, sir.
Can
Sir,
you see the slide, sir? It's on
no, sir.
the errors.
Calendar, sir. No, sir, it isn't calendar, sir. Right now, it isn't calendar. It shows your calendar, sir. Yes, sir. The errors, sir. Yeah. Before we need to understand that what is the term errors. So, if you establish a relationship y equal to a plus bx, that term which is called errors, which is something which is the unidentified factors or unidentified variables or unidentified undiscovered variables, we have been kept as the like so you are always stating you are proposing a models or a relationship, the causing and effect relationship. There's some term which is called error term. We have been excellent. We are used the excellent as a term using to denote the error. How much is that error? They're close to the limited error, which means the model has having a very vibrant. Like you see that the any models which is proposed in the industry analysis like Porter's 5 first model or BCC matrix. They have been framing that to such a way. It is all they've been defining this two variables like a market share and the relative market share and the what do you call it, see, and the market share, and one more the growth portion. That is the condition, growth rate and the market share. These two variables only it is identified by the industry positions where your business segment is fitted. Like apart from that, there are other factors also will tell that, but they have been seeing that these two factors are it's enough to, in the sense not enough, I cannot say that it is more appropriate to define the where it be, the industry will be fitted. Like a similar way, the errors, before we understand, we go for this regressions, we need to understand that the data is segmented in the secondary data. So far we are talking about the primary data, the secondary data, time series data. So we should understand the time series data, cross sectional data, and the pool data or the panel data, whatever that you can understand. What is the time series data? Time series data, something which is represent the time. So the profit for the last 5 years, it is called as the time series data. The time is then highlighting the data sets, which is called as the time series data. And the next is the cross sectional data, time series data along with this, which is 2 years, which is the year, as well as the one more thing, which is a profit along with the sales. If you are keeping those two information, it will become a cross sectional data. And if you make it as the panel data, the company A, company B, further divisions that you have been seeing, that it becomes the panel data. The panel data and time series data and the cross-sectional data. You have to understand that. In the this particular secondary data selections, tool selections, you have to use which type of data that you have been used. That is very important. Like we have seen in the primary data, like on nominal, ordinal, interval. Similarly, here also you have to see that the which type of data you have been using, time series or cross sectional panel. That depends upon that you are going to use your one selection of what you call the tools. It's very important here. But only the major the it's not like a major difference what you've seen in the primary data selection. Yeah, you're not going to see in this uh, uh, the secondary data choice of selections. But the thing is, there are the specific data sets you have to use appropriate tools like a panel data. You can do this type of data, and when you're proposing the model, you have to use you consider the as a panel wise. That is very important. And the errors term, which is unidentified, undiscovered, or undiscussed terms, which is called as the errors terms. Yes, sir. Next, sir. Next, sir. So it is a model which it has been proposing dependent variable, independent variable. You have been aware of this coefficients and the independent variable, random error variables. This is what actually the model are proposing model. And next, sir. Next, sir. Independent variable. Multiple regression models, which is, I think you need to one more time you have to press, sir. Yes. So you can see that this is the theoretical model, like y is equal to see, actually this is a beta. It's not been very clear. Beta uh, beta 1 minus x minus 1. This is not so clear. So this is a theoretical model which propose like a, but something, this is the fitted model, like a y cap. This is a small y cap. This is a y cap is nothing but the fitted model. Theoretical model and the fitted model. This is a small difference. You can observe that when you're keeping that something like a you want to experience, then it is called as the theoretical model. When it is fitted model something you have been proposed and it has very well validated and you are going to use that. It is called as the fitted model. Yeah. Next, sir. Next, sir. The factor R square, very important. What is R square? R square is necessary to lodge more and more regressions, which is At the same time, the time is the ability of the model to predict the diminishing. So R square is will tells that what kind of a relationship it is. See, R is will tells the establish the relationship between x and x1 and x2. Whereas the here R square will tells that the what is the relationship as a cause and effect relationship. At the same time, this is the R adjusted R square, adjusted R square after adjusting with the error term. As I told you that error term, which is we have been defining the error term, and we have been adjusting that against the divided by the what you are the R square that you have been getting. That's called as the R adjusted R square. Yes, sir. Yes, sir. Both you will get an output as in SPSS or any softwares that you have been using. R square and R adjusted R square you can use. Some are using that adjusted R square, some are using the R square. So it is up to them because when you are proposing the model, which is R square, is next is very important. The F will tells that the this also F will tells that the as much as the high F model will be the if the model will be fitted ratio is so what you call the good model fit you can be referred through the F things. For example, you are taking this the same R square. But thing is, the F model which shows that F is which is the having a high F value at the two different models proposed model that you can be preferred because the high F values will tells that the high amount of the fitness, which is the what you call the what you say the model fitness are more in this F values. Yeah, the next. So I'm being making a simple definition because I don't have time to go more further. So within 10 to 5 to 10 minutes, I'll be covering up this. So next, sir, next, sir. So next, sir.
Can you
Next, sir.
see multiple linear
No,
regressions?
yeah, no, sir. I'm seeing only the calendar, sir. So for no, sir. You're trying to share, no, sir. Nothing has come, sir. Yes, yes, sir. Multiple linear regression. Yes, 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 sir. This is fine, sir. This is fine. Lee Quantum Motor is planning the expansion. Management wishes to predict which sites are likely to be profitable. They have been using the several predictors profitability. So the profitability is the Y. You can see the understand that the relationship. Y is here the profitability. X is the competition, market awareness, demand generators, demographics, and physical quality. All are in the X variables. X1, X2, X3. You can be rated like this. So next, sir. Sure, next, sir.
Change, sir. Just a little bit.
Yes, sir. Yes, sir. Yes, sir. Correct, sir. Correct, sir. So you can able to see that the profitability and these are the things which is a competition, the market awareness, and the customers is the factors in that there is a variable, one variable to community income and the distance down. So all which is called as the try to explain the profitability. Okay, all these explanatory variables, the x variables, independent variables. Yes, sir. Profitability is the y. So now that is the conditions. What we will make the uh, regression model. So because one factors may not be indicates the entire thing, like a price cannot demand is described demand. But apart from the price, also apart from that, the customers loyalty, discounts. So many factors would be there for that setting at the demand. Not only the price. Am I right? So it is not fixing of the price. Price is the prominent factors, prominent variable. But thing is, it is you cannot be always stitched to the price. There are the people who see that the brand value, brand image, something like you can be expand many variables. You can be expand. Yeah, see, like you can see, I'm getting the results, which is the margin, like the predictive variables, which is 31.7.1 is the my R square, because I'm not going to show. Anyway, this just an for indicates the 815 rooms within 3 miles, the close 3.4 miles away, 4 lakhs. So this is what actually I'm getting the equations. Okay, I'm getting the equations, which what I fitted the equation, I got the answers like margin. If I get as 37.1 percentage, I'm getting the what do you call the uh, margin percentage I can get with referring the this value. 3815 rooms within 3 miles closest to that, 4,76,000 square feet, 24,500 college students, 39,000 median household income, 3.6 miles of distance meter. All together considered, I've been getting the 37.1 percentage as the my the approximate, which is the R squared value, which is the R squared value, which means regression value, the relationship value. I'm getting 37.1 percentage. The predictions can I'm getting like this is the model I've been proposed earlier. You have seen that the model which was proposed. Now I've been getting this. The next is I'll be taking the vacation homes. Like you see that the three factors you have been taking, that the developer specialized the summer cottage properties is looking at the lakh side. It's he wants to estimate the selling price of the individual lots, lot size, number of mature trees, and the distance of the lakh. So he gathers 60 nearby lots, which is they conducts a regression analysis. Yes, sir. Yes, sir. Yes, sir. Next slide, sir. Yeah, you can see that this is the summary output that I'm getting in the statistical side. You can look at this R square. I'm getting the R square, which I told you know that relationship, the coefficient, which you have to take this. Last time I've been explaining how much size, distance, that will, you have to take the coefficient value. Okay, from there, that is what the x1 proposed value b into x1. That is what the value you have to take. You see here my multiple R square, which is the multiple R, which is nothing but the correlation results. You have to understand the R values shows that correlation. It says 49% between, without defining the cause and effect relationship. The R square tells that 0.24, 0.24, and then adjusted R square 0.20, which means it has only the minimal relationship. Here, no hypothesis. Please understand, no hypothesis we have been proposed here. What we have been seeing, that we have been seeing the relationship, it is very well explained. R square, it is 0.24, which means that what kind of 24 percentage only it has the relationship. The overall, the my output, which is the what is the y, which is indicates that vacation forms, which is determining the vacation forms, and that to determine that will be 24 percentage. What we consider the variables will give the relationship: lot size, trees, and distance. These three variables are explained. What is my proposed y, which is three explanatory variables, will give the R square value of 24%. It is very, very minimal. Why? Because remaining 76% are something else, which we are not able to find out which is the prominent factors, which is the highest factors, which is the major factors. We are not able to identify. This is the very low R squared value. The R square is very minimal, which we cannot be proposed this model. We have to add little more variables. We have to find out that which variables are. We have to have a little more combination of variables, or we can remove some variables. This is what actually we try to do this. We try to do this, and which would be the which model suits to give the best way of the R square. We have to take that R square, at least we have to take 0.50%. That is 50%. That would be the nice. 70 is sometimes expected 0.70, but at least you have to make it 0.50. That is the best way of model. And F value also, you can see that the F value ANOVA tells what is the significance levels. Is here it is 5.97. So some model, other model, you can add little more variables, try to see that the F values are increasing. Similarly, R score is increasing. Then you can choose the which model would be the right one. So it is an exercise to you. You have to add up one more variables. You have to identify one more variable. So where you can identify the variable, you have to have a sufficient review of literature. Sufficient review of literature. You have to be connected while choosing the variables, the factors. Okay, this is very important. So while assigning the variables or factors, you have to connect with your review of literatures. There you can get an idea which variables you can more prominent one that you can take, and you can make a model, best model. Yeah, next sir, next sir. Yeah, next is very important, multicollinearity problem will comes. What is the multicollinearity problems? Sometimes you have to understand that your R squared may not improve. R squared may not improve uh, because of reason would be multicollinearity. Why? Because x, x1, x2, x3, x4, x5, five variables have been defined. And let's take x1 and x3 variables are close to each other. Close to each other means any one variables can explain the same attributes. Let's take same attributes, same effects. If you are keeping the five variables in the model, what will happen? Your R square will be limited. It's called as the multicollinearity problem. Multicollinearity problems, it is your R square may not be get improved when you are having a more number of more than two x1 x2. If you are improving, if you are adding more and more x1 x variable independent variables, you have to refer that which variables are having the same attributes. Either one you can be dropped. You can, for example, x1 and x3 are the same attributes, are explaining the contributing the same level of amount of consequences. That is the case, at least one you can be dropped and one you can be continued. That way you can be reduce the R square, what do you call, you reduce the collinearity problem and increase the R square value. That is very important. R square value, it is high correlate with the multicollinearity problem. Sometimes I told you that there is a 24%. Sometimes there's a problem because of not what you choose in the variables. The variables among that one variable, two variables, three variables are closely connected each other. That is the case. You can drop that. You can drop the two variables. At least you can maintain one variable so that you can improvise your model. This is what called as the multicollinearity problem. So there are a lot of problem which you can do this. So thank you very much for patiently listening. So there are a lot of hindrances which both sides it's happened. I don't know because of technical side. Kindly excuses me. So if you have any questions, please raise that. Any questions, sir?
Yes, thank you, sir, for that